this is 5.6, number 23, and we are in this section adding and subtracting fractional expressions. Now, in order to do that, if you remember, when you add and subtract fractions, you have to have a common denominator. So we need to find out what our common denominator is here. So I'm going to kind of come off to the side. And I'm going to factor t squared plus t. I could take a t out of that, and then you'd have a t plus 1 left. Okay, now what about t squared minus t? I could take a t out of that and have a t minus 1 left. So if I replace these, if I look at what would be the greatest common, the least common denominator, the least common multiple is the least common denominator, well, they'd have to have a t in it. Each of them need a t plus 1, and each of them need a t minus 1. If you remember, you need one of each factor the most number of time it occurs in any of the denominators that we're looking at. So if you look at it, t squared plus t up here, it already has, if I'm looking at this one, it already has a t and a t plus 1. It needs a t minus 1. And so I'm going to put this in parentheses. And if I multiply the bottom by something, I got to also multiply the top by the same thing. Now if you look at t squared minus t right here, it has a t and it has a t minus 1 already. It needs a t plus 1. So I'm going to multiply it by t plus 1 to give it this common denominator that we found down here. Everybody has to have all the same stuff in the denominator. Okay, so now what do I have in the denominator? I'm getting ready to add, so I'm going to put them together. I have a t squared, I'm just going to write out the factors. T times t minus 1 times t plus 1. That's our new denominator. It's right here, and I just made that happen in all the other ones. And on the top, if we look at what we had, I have a t minus 1 from the first fraction, and then I have a plus, and I have a t plus 1 from the second fraction where I gave it the common denominator. So now if you look at the top, the minus 1 and the plus 1 are going to add to 0. I'm going to have t plus t is 2t. And on the bottom we have t times t minus 1 times t plus 1. Now the reason I left that in factored form and didn't multiply it all out is because now I can see what cancels out. I have a t that cancels out here and a t that cancels out here. Now remember, I couldn't cancel that t out with this t and this t minus 1 or this t here because those are part of an expression and you can't break those apart like that. It has to be exactly the same thing on the top and the bottom if there's an adding or subtracting sign. So what I have left now is my answer. It's 2 over t minus 1 times t plus 1. And I don't know how your book's going to give that. Let me just draw that fraction bar out. That's a perfectly fine answer. The book may multiply it together in the answer key. I don't know because I don't have the answer key in front of me right now. But if you have t minus 1, t plus 1, that's a difference of 2 squares, and that means that would be t squared minus 1 squared, which would just be t squared minus 1. So it may give this answer or it may give this answer. They're the same. It just depends upon if you want to leave it in factored form or multiply it out. Okay, this is 5.6, number 25, and we're trying to subtract two fractions now. And again, we need a common denominator. So here's what I'm going to do. I'm going to do this one a little, I'll organize the work a little differently this time. What I'm going to do is I'm going to factor x squared minus 1. That is a difference of 2 squares, and it factors into x plus 1, x minus 1. Now over here I have 1 over x minus 1 times x minus 1. All right. Now if they need a common denominator, what I notice is they both have at least one of these x minus 1s. But this one on the left needs a second x minus 1. So I'm going to multiply it by x minus 1 over x minus 1. Okay. And the one on the right needs this x plus 1. It doesn't have it, so let me give it to it. X plus 1 over x plus 1. Okay. Now they got a common denominator, and the denominator is x plus 1 times x minus 1. I'm just going to go ahead and write it out all in factored form. I know I could write that x minus 1 squared, but just for now I'm going to leave it like that just to see what happens. Now I've got to be careful about the top because I'm subtracting. I have an x minus 1, and then I have a subtract, and over there, what am I subtracting? I have that x plus 1, and I'm just color coding here so you can see where I'm pulling those terms from. They have a common denominator, so we can say they got the same denominator. Let's just go ahead and subtract across the top. Now let's write this all out, because that's x minus 1, but that's a minus x and a minus 1, okay, over all the denominator. I'll write it down again. Okay. Now let's see what cancels out on the top. X minus x would add up to 0, but I have a negative 1 minus 1 would be a negative 2. So that's going to be a negative 2 on top, and on the bottom we're going to have x plus 1 and x minus 1 squared. Now, I don't know if the book's going to multiply this out or not. To me, this is a perfectly fine answer. I'm going to leave mine like this. You could multiply the whole denominator out, and if you did that, you would get x plus 1 times x minus 1 would be, I'm just going to do the x plus 1, x minus 1 would be the difference of two squares. That would be x squared minus 1 times x minus 1. And then that would be x cubed minus x squared minus x and a plus 1. So if they multiplied it out, if the book says something different, it might be that they have this instead of this down here. And if they do have this x cubed minus x squared minus x plus 1, that means all they did was multiply that expression out. I would just prefer for it to be left like this in factored form when we take tests, unless you get some kind of multiple choice test, and that's, you know, on the denominator there. But you just need to know that you could multiply it out if you had to, but for all practical purposes, I would just assume you leave it in factored form like I circled, and we'll circle again right here. All right, this is number 27 on 5.6, and of course, in order to see, we are subtracting two fractions, we need a common denominator. In order to get a common denominator, we need to look at the factors of each one of these. So let me rewrite them in factored form. S squared plus 2s plus 1. Let me go ahead and put an s here and an s here, and we think, what multiplies to give me 1 but adds to give me 2? Well, 1 times 1 is 1, and 1 plus 1 is 2, so it will be plus 1 plus 1. Okay, now I'm going to come over here. I'm going to leave some space so I can write my common denominator in. This s squared minus 1, that's the denominator of the second fraction, that's a difference of 2 squared, so it's s plus 1, s minus 1. Now, both of these fractions need to have the same thing in the denominator. What does this, the first one need? Well, it has, if you look, both of them have an s plus 1, right? This second fraction has a s minus 1 that this first fraction doesn't have. So let me multiply by s minus 1 over s minus 1. Remember, what I'm doing is I'm getting an equal fraction with the same denominator. So if I multiply the denominator by something, I've got to multiply the top by the same thing to keep the fraction equal. Now let's look at the second fraction. It has a s plus 1, s minus 1. Now this first fraction had an extra s plus 1 that this second one didn't have, so let's multiply it by s plus 1 over s plus 1. And now the denominators have all the same factors in them. They have two s plus 1s and an s minus 1. Since they have the same denominator, we're going to subtract the fractions, and when we subtract them, we keep the denominator the same. So I'm just going to write it out in factored form. Your book leaves the answers that way. I did go check between this problem and the last one. All right, so what I have on top, and I'll color code it, I have s minus 1 from the first fraction, and then I have a subtraction sign, and then I have s plus 1 from the second fraction in the numerator. Okay, so we need to kind of see what happens here. I've got s minus 1, and then this minus gets distributed to the s, and a positive 1 would be a minus 1, all over s plus 1, s plus 1, s minus 1. All right, so let's see what's going to cancel out. The s and the minus s add up to 0, and again I have negative 1 minus 1 again. That ends up being another minus 2 on top. We saw that in another problem here. And on the bottom I have s plus 1 times s plus 1 times s minus 1. Now the book may write it this way. They may put the s minus 1 and they may put a square on the s plus 1. And remember, the order in the denominator, the order that you write the factors doesn't really matter. And it doesn't matter whether they write it this way or this way. It's all the same thing. So just, make sure your answer is matching up to the key and that you have the same thing even if you, didn't put the square on it. Alrighty, that's it.